sponsored by
KBN Education Trust, Sindanur.
KBN Education Trust, Sindanur. Rural Institute of Open Schooling. RIOS ಮತ್ತು NIOS ಶೈಕ್ಷಣಿಕ ವರ್ಷದ ಪ್ರವೇಶಗಳು ಪ್ರಾರಂಭವಾಗಿವೆ. SSLC ಹಾಗೂ PUC ನೇರ ಪ್ರವೇಶ ಕೇಂದ್ರ ಸರ್ಕಾರ ಮತ್ತು ಕೌನ್ಸಿಲ್ ಆಫ್ ಸ್ಕೂಲ್ನಿಂದ ಅನುಮತಿ ಪಡೆದಿದೆ.
Welcome to Xtream channels. Now today you are discussing about the another part of an 10th standard geometry, that is in tangents to a circle at a different position. So if you know that already what is tangent, no, all of you know them. Tangent is a line which passes through the only one point on the circumference of the circle. You know that is a tangent. So if tangents points are different positions are. Now first one, tangents on the points on the circumference of the circle, or it is nothing but on the circle. If you know all of you there, if it is a circle, so point is there, no, that is only one point. This is we can draw the tangents. So if it is XY is a tangent, then it is only passes only one point, that is on the circumference of the circle. In each point on the circumference of the circle you can draw only one tangent, only one tangent. So in second case the point is inside the circle, point is inside the circle. What happens? So it is your point is here. What is that? In the point P can draw the line. So many line you can draw like this. So these are the lines are drawn, but these lines are not called as a tangent because inside the point the tangent cannot be drawn, but only if the drawn only secants because to cut the circle, but do not pass it on. So inside the point you cannot draw the tangents to the circle. But third position you can take on the circle, the point must be outside. P is the point outside, here it is. So how many tangents should be drawn? This one you can observe them. So first one will come like this, second one, and the third one, and fourth one, so fifth one you can so like this. But here in only the points of A and B, only two tangents must be drawn, but so many lines must be drawn, but instead of this one we can consider only two tangents. It means in the point on the circumference of the circle we can draw only one tangent, but outside the point we can draw only two tangents. In any circle the point is away from the circle, then we can draw only two, but not more than two. Each point we can draw only two tangent to the circle. So this is the tangent to a circle at different position. On the circle one, inside the circle and outside the point. Inside the circle cannot be drawn the tangent, so it is not the tangent, but these are the lines are called secant to cut the circle, but do not pass the circle. But in third case, if the point is outside the circle is there, then you can draw so many lines, but among these one you can consider AP and PQ. So this is the only, in every point you must draw two tangents, but not more than two tangents. So regarding about the point outside the circle, then the one theorem is that is important for the examination, that is 3 marks 1 question. So you know them regarding about the point away from the circle related to one theorem, that is theorem. So we can call it theorem number 1. So in that theorem number 1 is very simple, but not any difficulty. So what is that? The tangents drawn from an external point to a circle, number one, they are equal. Second, equally angles formed at the center as well as subtended angle at the outside the point. There is a theorem is there, no? That is very simple theorem is there, no? The tangents can be drawn from an external point to a circle. They are equal. Relate subtended equal angles at the centers and equally inclined to the line joining the centers and the external point. Centers and the external point. So you know this is the figure. Every theorem figure must be very essential. Without figure cannot give a mass. This is center. This is the external point. So you can PA and P. This is A, this is B. So AO and OB. This is B. So given. So what is given in this theorem? O is the center of the circle. P is an external point. O is the center of the circle. Center of the circle and P is the external point. External point and P is the external point. So to prove is done. Number one, PA is equal to PB. Second one, angle AOP is equal to BOP. And third C angle APO is equal to BPO. Now this one angle is equal to this angle, these two angles. So AP is equal to BP. Now first one, the external point to draw the tangent. Their tangents are equal means AP is equal to BP. Second one, angle subtended at the center AOP is equal to BOP. Third one, angle at the external point APO is equal to BPO. Then proof of the theorem. So in triangle PAO, in triangle PAO and triangle POB, there are the two. Now first one, AO is equal to BO or OA is equal to OB because radii of the same circle. Radii of the same circle. Radii of the circle. So angle OAP is equal to angle OBP because is equal to 90 degree because the tangent, because the radius drawn from the contact point. The radius drawn from the contact point. So once again, O given, O is the center of the circle, P is an external point to a circle. To prove, PA is equal to PB, second one angle AOP is equal to BOP, and third one angle APO is equal to BPO. Then we can say proof of the theorem. In triangle PAO and triangle POB, AO is equal to BO because radii of the same circle are OAP is equal to OBP is equal to 90 degree. The radius drawn from the point of contact ray, radius is always perpendicular. Is always perpendicular. So next, OP is equal to OP. It is because common. It is common. Therefore, triangle PAO is congruent to triangle POB because you say there are SAS, two sides, one angle, or right angles are taken because RHS. Therefore, number one, A is equal to PA is equal to PB. PA is equal to PB and for B. Then angle AOP is equal to angle BOP. And third one, see angle APO is equal to angle BPO. Hence, theorem is proved. Now this is 3 marks problem for a theorem. Here it is very important theorem. According to the theorem, then you get a very 3 marks. First step, the given you get a half marks, 2 is a half mark, and the proof of the problem is 1.5 marks, and half marks is the figure. Totally 3 marks figure. According to the scheme of evaluation, is also 3 marks. Is also. So this is all of you know. Understanding this problem. This very well you know them, you can easily understand, but it is a concept, basic concept should be taken in a 9th standard. Congruency of triangle and RHS properties, SAS properties, AS properties, among one property can use through the theorem because circle is there, no figure must be triangles or triangles are there, no. So that property can use through the tangents are equal. The equal angles at the center and equal angles formed at the external point to a center of circle, they are also equal. So this is the proof of the theorem. Then connected to theorems, there are the 2 types of problems are there. One is properties of tangents. One of the properties of the tangents. You take one example. One example is taken. In the figure, PQ and PR are the tangents to a circle with center O. Angle P is equal to 4 by 5 angle O. Find angle O and angle P. Angle O and angle P. Now this is one of the problems. There are 2 problems are given. So the given figure is like this. O, P. So this is OP. They are given for the OP and QR. Q. So given O is the center of the circle. O is the center of the circle. PA, PQ and PR are the tangents drawn from the external point. Next to angle O and angle P. Angle O and angle P. Proof of the problem. So what is the given condition is angle P is equal to 4 by 5 O. You know that angle Q is equal to 90 degree and angle R is equal to 90. Because the radius drawn from the point of contact. Is always perpendicular. So angle O plus angle P is equal to 180 degree, but it is remaining angles of the quadrilateral P, Q, O, R. Condition is given. One condition, angle P is equal to 4 by 5. Angle P is equal to angle O as it is. Instead of angle P is equal to 4 by 5, angle O is equal to 1. Is equal to 1. So take LCM is 5 is the LCM. 5 angle O plus angle 4O is equal to 180 degree. 5 plus 4, 9 into angle O divided by 5 is equal to 180 degree. Is equal to 180 degree. Is equal to 1. 9 into angle O is equal to 5 into 180 degree. Angle O is equal to 5 into 180 divided by 9. 9 1 927. Angle O is equal to 5 into 20. Angle O is equal to 100 degree. Therefore, angle O plus angle P is equal to 180 degree. The value of angle O is equal to 100 degree plus angle P is equal to 180. Angle P is equal to 180 minus 100. 180 minus 100. Angle P is equal to 80 degree. So hence angle P and angle O are equal to 100 as well as 80 degree. 100 as well as 80. So all of it very well understanding these problems very clearly. So easy problems are there now, but not any difficult. Students does not afraid regarding about the geometry. So easy are there. You can done one by one step to follow the basic concepts of the geometry. So thank you. I will continue in the next class.
This class is sponsored by
KBN Education Trust, Sindanur.
KBN Education Trust, Sindanur, ರೂರಲ್ ಇನ್ಸ್ಟಿಟ್ಯೂಟ್ ಆಫ್ ಓಪನ್ ಸ್ಕೂಲಿಂಗ್, RIOS ಮತ್ತು NIOS ಶೈಕ್ಷಣಿಕ ವರ್ಷದ ಪ್ರವೇಶಗಳು ಪ್ರಾರಂಭವಾಗಿವೆ. SSLC ಹಾಗೂ PUC ನೇರ ಪ್ರವೇಶ ಕೇಂದ್ರ ಸರ್ಕಾರ ಮತ್ತು ಕೌನ್ಸಿಲ್ ಆಫ್ ಸ್ಕೂಲ್ನಿಂದ ಅನುಮತಿ ಪಡೆದಿದೆ.